Alright, so in this video allow me to talk about the distributive property when it comes to fractions. In some of the other videos we talked about the distributive property when it comes to just whole numbers. If you recall correctly, if you had 2 and you were going to times it by 5 plus 4, you could do 2 times 5 is 10, and then you could plus it by 2 times 4, which is 8, and that's 18. Or you could have done, if you didn't want to do it that way, you could have done 2 times 5 plus 4, and then you could do what's in parentheses first, which is 5 plus 4 is 9, and then when you times it by 2, it equals 18, okay? So this is the distributive property. You do 2 times 5 and then 2 times 4, all right? And the way you could use that, to make things that seem a little more complicated a little easier. So for example, say you had 8 times 63, all right? You could change that 63 into 60 times 3, so you could do 8 times 60 plus 3, all right? And then you could do 8 times 60, which is 480, and then 8 times 3, which is 24, and then 24 plus 480 equals 504. And you can verify that with your calculator, and indeed 63 times 8 is 504. Alright, so that was the distributive property when it came to whole numbers. Now let's take a look at distributive property when it comes to fractions. So let's look at something like 2. Oops, can't really see that one. Let's change that. So 2 times 7 divided by 8 plus 4 divided by 5. Okay? Well, the way you're going to distribute it is you got to remember that this 2 is really 2 divided by 1, right? You can this is an integer, right? And even an integer is a fraction because you can always divide it by 1. So anyway, just remember that. And when you times this 2, you can times it there, and then you can times it there. So now it's 2 times 7/8 plus 2 times 4/5. All right, well, 2 times 7 is 14, so it's 14 over 8, and then plus 8 over 5. Okay, and then you're going to plus them together, and when you plus them together, you need to find a common denominator, and you want it to be the smallest common denominator or the least common denominator, and in this case it's 40. So we need to times the top and the bottom of both the fractions in order to get 40. So what equals 40? Well, 8 times 5. So put that there, and put that there, and then this is 8. 8 there, and 8 there. Now, when we times them together, we're going to get, let's see here, 8 times 10 is, 5 times 10 is 50, and then 5 times 4 is 20, so that's going to be 70 over 40, and then we plus those together, and then we get, what do we get? We get 64 over 40. And then when we plus all that together, we're not going to plus the denominators, we're just going to plus the numerators. And when we plus those together, we're going to get what? 134. Well, let's use a different color. You get 134 over 40. Okay? And that's pretty much it. Now, that's an improper fraction. We could make that proper. And the way we do that is we could reduce it if we wanted to. And how could we reduce that? Well, you could divide both by 2. And when you divide this by 2 and this by 2, we're going to get 67 divided by 2. Divided by 20, I meant to say. Let's get some room here. All right. And what is 67 divided by 2? Well, you could do it like this. And how many times does 20 go into 6? It doesn't. How many times does 20 go into 60? It goes into 3 times. So then you have 60 here. And now you have a remainder of 7. So it's 3 with a remainder of 7. Or 3 and 7 over 20. So let's rewrite that here. It's 3 and 7/20. And there's the answer. That's how you would use the distributive property with fractions. Let's make some more room and we'll go over how to use the Pythagorean theorem, or fractions with the Pythagorean theorem formula. So let's see here. Say you have a triangle like so. It's a right angle, all right? And let's say that, and this is A, and this is B, and this is C, okay? Now the Pythagorean theorem, all right, is this: c squared equals a squared plus b squared, okay? Now, let's say that a, all right, a equals 1/4. And let's say that b equals 1/3. Okay, so again, this equals 1/4. This equals 1/3. Okay, we need to know what C is. So C is a question mark. Okay, so we could plug this in into this formula. So we have c squared equals 1/4 squared plus 1/3 squared. Okay? Well then, what we have is we have c squared equals 1/16 plus 1/9. Okay? And then, after we have that, we need to plus these together, okay? Well, what is a common denominator of both of these? Well, in this case, it's going to be 144. And in order to find that, we need to times this by 16, and this by 16, and we need to times this by 9, and this by 9. And now what we have, let's make some room. Now what we have is we have 9 over 144 plus 16 over 144. And then of course this, all this equals c squared, okay? And then we're going to plus those together, okay? So when we're plussing fractions, if we have the same denominator, we just plus the numerator. So now what we have is we have c squared equals 25 over 144. But now we need to get c by itself. See, it's c squared. We just want one c. We don't want c squared. So now what we got to do in order to get c by itself, well, c squared, in order to get it just to c, we have to square root c squared. And if we do one thing to one side, we have to do it to the other side, so we square root this side as well. So now we have c equals, well, what's the square root of 25? Well, that equals 5. And what's the square root of 144? Well, that's 12. So the answer to the original problem, which was, if you recall correctly, it was a triangle with a right angle right here. We had A here, we had B here, and we had C here. And we said that A equaled 1/4, and we said that B equaled 1/3. And we wanted to know what C equals. Well, from this point to this point, C equals 5/12. And this was all in meters, so A is 1/4 of a meter from here, and B is 1/3 of a meter from here, and C from here to here is 5/12 of a meter. And that's pretty much it. So that's it for this video, and we'll be making a video later on, and hope to see you on that one as well. All right.